Good afternoon and welcome to this, the first of the semester session to the CERIAS Security Seminar from Purdue University. I'm Joel Rasmus, Managing Director, and it's my distinct pleasure to be able to introduce our guest speaker today. Our speaker is Mr. Ambrose Kam, who is a Cyber Chief Scientist and Fellow with Lockheed Martin. Mr. Kam is considered a pioneer within the industry, as he was one of the very first to start applying modeling, simulation, and operations analysis to threat modeling and cyber resiliency assessments. It's our pleasure to have him with us today. Ambrose, it's all yours.
All right. Thank you, Joel. Appreciate it. And thanks again for having me here today to kick off this new season or this new semester here. So my name is Ambrose Kam, and I'm from Lockheed Martin. Been with the company for 20 years. I started it in 2020. 2003, and so this will be my 20th year with the company. Previously, I also spent a few years with other companies within the DoD industry. But the thing that I'll be talking about today is really on applying multi-agent reinforcement learning in a cyber wargaming environment. So what is the motivation for this talk here? Why are we doing what we are doing? So I guess first of all, what I would like to do for our activity here is that we would like to develop this AI-based wargaming capability to better identify potential exploits or tactics, techniques and procedures, TTPs that might be previously unknown. I think that when we do so in the cyber industry, there's a term called red teaming. So basically, you're playing the role of the adversary trying to break into your system. The goal is really to identify potential weaknesses in your system. And once you know the weaknesses, then you can come up with ways to mitigate these security flaws or security weaknesses or weaknesses within your system. So that's really the whole purpose of this. But we wanted to kind of take another step further, right? Instead of always having a human person doing the what we typically call red teaming, we would like to maybe use AI machine learning to do that, to at least help us identify high-level exploits that the adversary might be able to take advantage of. Because as human cyber operators, we know what we know. We are kind of somewhat limited to the knowledge and maybe previous experiences that we have, and so we may not be able to see to identify weaknesses like others, like the adversary, for example. And so there was many benefits to this approach. One is that in many cases, some of our systems may not be fully developed yet, and we want to be able to start, exercising this kind of assessment to identify new or emerging attack vectors. And in the DoD industry, that's certainly the case. We have. I mean, I work for Lockheed Martin, and we have new systems, new platforms coming down the pike as always, and you really need to step up your game to do this kind of red teaming. The other thing is that a lot of times it's always more costly to retrofit cyber solutions once the system has been deployed. I mean, obviously, yeah. So once you push out a system, the system is already in the hands of the end users, and then you find out there are some problems. I mean, that's avoidable, but to the extent possible, you need to at least try to find as many weaknesses as you can before you hand it over. This can be a airplane, or it can be enterprise-wide computer network or something like that, or maybe it's a cell phone infrastructure. But the important thing is to be able to identify as many exploits early on, so that you can come up with solutions, or at least mitigations plans before you roll it out. And then the other thing is that we will also want to use this as an opportunity to improve the resiliency and the overall robustness of the system. And so that's really key, because I mean, nowadays the adversaries, they're not going to stop at doing whatever that they can to to meet their objectives, whether it is stealing your personal information, or in the case of DoD, maybe they want to disrupt the operations of our airplanes or ships or whatever. So that's really important. So the concept of resiliency is important. And I also do want to point out that resiliency doesn't mean that you catch all the threats at all times, because you may or may not be able to do that. But resiliency actually means that even if there's a cyber event that might be happening, your system or system of systems can still continue to operate. So that's really the concept of resiliency there. And in the case of DoD, or maybe even in the civilian world, when you don't really have the system yet, or you want to be able to have this kind of capability. And so our approach is to leverage reinforcement learning, and and we have demonstrated that we know how to use reinforcement learning to kind of augment the human operators, so that the human cyber operators or cyber professionals, you don't need to sit in the lab, for days or weeks or months at a time to discover these vulnerabilities for red teaming purposes. We would like to kind of be able to augment, what they already have, the kind of capabilities that they already have. And then this multi-agent will also help us, not only that we have single learning agents, single learning agent working, but we also wanted to have a multi-agent reinforcement learning framework. So that's important. So the other thing I would like to kind of point out is the concept of wargaming, right? So a lot of people, think of wargaming as like, have tanks and airplanes and, flying in the real world and they shoot at each other. Yeah, that's kind of wargaming too, but there's also the simulation aspect. It doesn't have to be real. It can be kind of virtual in the sense that you can use simulation or modeling simulation tools to augment that. So I have a kind of a definition from NATO of what is a war game. So from their perspective, it's a simulation by whatever means of a military operation involving two or more opposing forces using rules, data, and procedures. And really, the idea is to depict a possible real world event, so that the operators can better anticipate what might be happening if there's a conflict there. That's more of a military kind of thing. But in the civilian world, if you look at the bottom there, that's a quote that I took from Deloitte, which is one of the consulting firms. In the cyber world, there's also the concept of using similar techniques, cyber wargaming, in the commercial world as well. So I don't want to give people the impression that this is the only thing that we are doing in the DoD world, and that's no relevance to the commercial world or the civilian world. That's definitely not true there. I mean, as a matter of fact, the whole purpose of cyber wargaming is really to raise the awareness of cybersecurity threats, and using this as a way to improve or enhance operator training, so that they can better anticipate real world threats later on. And so that's important. Here's a chart, or at least this figure, that I kind of reference from the MITRE folks. So MITRE is a federally funded research and development center, or FFRDC. I actually spent a few years with MITRE as well. And then they actually came up with this concept of wargaming reference model. I kind of added the word cyber there, but essentially what they are talking about here is that you have red team and then blue team. So maybe red team is focusing more on the defensive side. Blue team is focusing more on the so the red team might be focusing more on the offensive side. The other team, say blue team, might be focusing on the defensive side. And they kind of act out this kind of scenario. So you have different turns, and within each turn you have different moves. And so at the beginning of the turn, maybe the red team picks a course of action to attack, say, the blue side, and then the blue side is trying to do something to mitigate or at least address the those threats. and then the system states got updated. Because if it's a case of, say, tanks and airplanes, flying and shooting at each other, there's a matter of adjudication. Like if there's a missile that's being fired, did that missile kill the target, for example? If it's a kind of a Wargaming DoD kind of thing. But in the cyber, it's not so much about physically like destroying an asset. It's more about maybe shutting that asset down for an extended period of time, or maybe disrupting its operations, that sort of thing, or maybe stealing some data or something like that. So, but nonetheless, my point is that there is a red team versus kind of blue team. You have multicolor team, and then you have the white team that's kind of in charge of the execution of the scenario, and that the same white team may or may not have the people, the experts, subject matter experts to perform the adjudication. And so so if we kind of extend that concept and then applying this to the cyber wargaming, it's kind of similar. You would have a cyber adversary, they have some kind of offensive playbook, and then out of that playbook, they're going to, select some kind of play. And then on the defensive side, the cyber protection team, they would also have a defensive playbook, and then they also pick a play, and then they kind of act out. It's kind of similar in the DoD world where they conduct the wargaming. So that's the kind of the typical definition of wargaming. Peter Perler, who is kind of a grandfather in wargaming, if you will, they have so he has a book that kind of talks to this, and so he's the well-known figure in the wargaming world, and they have kind of he has documented a lot of these concepts there, and what is the definition of wargaming versus, let's say, a tabletop exercise, for example. So there's a lot of nuances, and I don't want to get too much into that, but for this effort that we are doing, I'm kind of calling this as a wargaming, because there is both sides, offensive and the defensive side. Doesn't have to be red versus blue; it can be red versus purple if you like. But that's and really the whole point is that you have two teams, two or more teams, I should say. So again, going back to what I was saying about the offensive playbook, we as in the cyber professionals here, we need to come up with the offensive playbook or the defensive playbook. So in the offensive playbook, it might be a collection of TTPs, tactics, techniques, and procedures, or maybe potential attack vectors. And they can come from attack patterns from the KPAC database. I have another chart to talk to that, but take my word for it. So the KPAC actually has a list of high-level attack patterns that the adversary could use. And then there's also the CVEs, which is common vulnerability exposures, and also the Q chain as well. And so collectively, we come up with this kind of playbook. Same thing with the defensive side. You also have the NIST standards out there, NIST 853A, for example. That's where they have all the security controls out there. And then you have CSA, cyber survivability attributes, and also 800-160 volume 2, for example. That's the cyber resiliency techniques out there. And so collectively, we come up with this playbook. It's the way that I would describe it is similar to how you, if you guys are familiar with, say, American football, right? So in American football, you have two teams playing against each other, but each side, they say whether the offensive side or the defensive side, they have their own playbook. So the offensive, coordinator, they would, go to this playbook, call up a play. Same thing that the defensive coordinator will also call up a play, and then they kind of act it out, play it out. Same thing here. So it's similar concept, I would say. But to kind of augment, to kind of categorize and kind of group all these, TTPs and attack vectors together, we leverage something like the MITRE's attack framework. So again, it's a framework that's freely available, and as a matter of fact, I posted this link here. You can go to it, or you can just Google it. But basically, what you have is if you can see my my desktop there. So this is the same attack framework that I copy and paste for that slide there. And so at the top there, so each column is they are the tactics, and then the rows are the techniques. So you have columns by row by columns. So you have techniques for each one of the rows, and then at the top is those are the tactics there. And so we would like to group them together. And the reason why we did that is to better organize the playbook that I described. And then same thing with the defensive side. There MITRE also came out with this defense framework. I think it's fairly recent, maybe last year or maybe 15 months ago. It's fairly recent. So so again, you can Google it. Is industry kind of an industry standards. A lot of people, cyber professionals, they reference attack framework and defense framework. And so you can kind of take a look at that. Same thing, there's in terms of organization, similar to the attack framework. At the top, those are the tactics, and then the rows are the techniques. And so that's how attack and defense framework got organized. But going back to what I was saying, the interesting thing about the attack and defense framework is that there is for every attack vector, there's also the corresponding defensive technique that you can address. So this is kind of an example of that, as far as how you want to, if the adversary want to attack, say, your account or something like that. And I'm just kind of using it as a very generic attack vector example. How would you, on the defensive side, how would you address that? So one way might be to harden your hardware, maybe to harden your credential as well. Maybe you want to enable your multi-factor authentication and things like that. So there are different ways that you can build your strategy. But the point that I want to make is that there is for every attack vector, there's a corresponding defensive scheme, if you will. And so there's a kind of a relationship there, and that's going to be important in the next few charts there. I wanted to kind of plant that seed in your head there. And then, so this is one example of how the attack framework can be used. So you can see here, this is the attack technique that I share with you there on the screen. And then there's the mitigation, and then the effects, and then the corresponding security controls that may be used to address that particular given technique, for example. So that's part of the 800-160 volume 2 there. And so that's pretty good, right? Because now we can, like I said, we are using the attack framework on the offensive side to kind of organize the TTPs and the attack vectors, and then on the defensive side, we can also do the same. We also, so I would also like to mention about the KPAC and the CWE, which is the cyber weakness enumeration, and the CVE, which is cyber vulnerability exposures. And so KPAC is a collection of attack patterns, and basically tells the end users how the weaknesses within the system can be exploited. And then the CWE is a root cause of that weakness there. And then the vulnerability would be a little bit more specific. Given the fact that there is this security gap or this security weakness on the system, what are the vulnerabilities there? So there's reference databases for each one of these, and we basically collected them. And so this is one example of it. Again, this is open source. Anybody can access this. So this is an example of a, say, rainbow password hack, for example. And the reason why there is this attack pattern of rainbow password hack is because there is a weakness in the password requirement on the system. And how do the adversary take advantage of that? So there's a whole bunch of CVEs that are associated with a weak password. for example. So so the idea is that there, for each one of these attack patterns, there's corresponding CWEs and CVEs, and that's the point I'm trying to get at, and how we can kind of group all these concepts together. This is the kind of a diagram that kind of shows you the relationship between the CVE, CWEs, the KPAT, but also how they are related to the attack and the defense framework there. And so in this case here, there are specific, weaknesses that there would be, some kind of CVEs that can be exploited. And that leads to, some kind of, attack patterns from the KPAT. And then the attack tactic or technique can implement those attack patterns. And then on the defensive side, how can you, address these security gaps? And so that's the example that I was trying to show you. And so why are we doing this? Okay, so the reason why we are doing this, as I told you, we need to have playbooks, and then so which is important. The other thing that we are also doing, that's in the domain of AI machine learning, is that we need to have some kind of database to train the learning agents. So I actually have a few charts that can't talk to reinforcement learning, but just to give you a preview, when you set up your learning agents, you need to be able to train it, right? Because the learning agents, they don't know anything at the beginning of the episode. So you need to train the learning agents, and we need to use industry standards to train these learning agents, because it's one thing that, somebody from Lucky Button, like myself, says something, oh, this is the way that you attack a system X, I don't say Windows 11 or iPhone 12 or something like that. But is it another that, hey, that we're actually using industry standards, so we provide the traceability. People have been doing performance testing. They have identified these valid exploits, and so the whole industries know about them, right? It's not just I make something out. It's not like that. So that's important to have some kind of foundation from the credibility standpoint. And then secondly, we can use this knowledge base or knowledge graph, if you will, to train the learning agents. And that's the next thing that I'm trying to get at. So the idea is that that the human operators, or in the case of learning agent, they can actually compose these different attack vectors. So I kind of use the analogy of your different Lego blocks. You may have different bins, right? These bins might be the tactics and techniques that I show you about, and it's really up to you if the human operators are part of the cyber war game to compose this, or if it's a learning agents, they need to be able to take these Lego blocks from these bins and be able to compose something. And that's the whole idea. And that's what this diagram is trying to show you, is that the VORTEX is our database. So in our case, we are using a Neo4j instance, but you can use whatever that you want. The idea is that you have some kind of knowledge base that resemble like a playbook, offensive playbook in this case here, because that's the cyber attacker in this chart here. So the idea is that he's going to call up a play from this playbook, and there will be that, and based on whatever the defensive side might be doing, there might be some cyber results. And so there's the action and then reaction. So similar to how you would play out like in a football game, essentially. So how do we want to apply this in the AI machine learning domain? So this is the same chart that I showed you earlier, except that I replaced the human person on the left-hand side and on the right-hand side as well. So it's not just two human people, playing against each other, or two teams of human players playing against each other. They can be, two groups of learning agents playing against each other. Or you can have a hybrid situation where you might have, one team that's controlled by learning agents, and then the other team controlled by human operators as well. But the concept it's very similar. Is that instead of having human operators calling the plays from the playbooks, you have AI machine learning agents to call up those plays. And in our case, we are using reinforcement learning. And the reason why we chose why we went down this reinforcement learning path is that it takes a lot of data to train the learning agent for like supervised learning. And this is the next thing that I'm trying to get at, is that once we have established this wargaming environment, how can we evolve it to better leverage AI machine learning? So the figure on the left there kind of shows you kind of a like a Venn diagram to show you what AI is really about and how does it, compared to machine learning. It's a subset, right? So basically, AI is something that that's trying to mimic the human behavior or the way that humans think, but then a subset of that might be, machine learning. It's actually focusing on the learning aspect. It's not so much just to replicate human behaviors or human decision making, but also actually the machine is actually learning. So it's actually a subset of that. And then you have deep learning, and then you have reinforcement learning. So the chart on the right basically shows you that there's different paths of AI, and we are focusing more on the decision making at this point there. And so that's what we are focusing on. And then within machine learning, as I mentioned, there are like different domains or different types of machine learning. So you have supervised learning, where you are providing explicit, feedback. So it's like you need to have large volume of label structure data for supervised learning to work. And then you have unsupervised learning. It's kind of similar to you allow your kids to drive your car. They don't know how to drive a car at the beginning, but you don't give them explicit instructions. You just let them drive, and they might run over say the garbage can, or hit the curb, scratch your wheels or whatever, or they might even hit the other cars too. But overall, you're hoping that your kid will learn how to drive a car, after so many accidents or whatever. But reinforcement learning is a little bit different, right? Reinforcement learning is actually providing feedback, providing rewards. So there's an objective function and there's rewards that are associated with those with the objective function, essentially. And so that's the one that we chose for our use case here, because I found out it's very hard to get a large volume of label structure data for cyber, and especially in the Department of Defense use cases. So for our use cases, we chose to use reinforcement learning, but other people might choose something else different. This is kind of like an overall overview architecture of what a reinforcement learning is really about. So you typically set up the learning environment. You have agent, in this case here, one agent is trying to make some kind of decision. As I said, the agent doesn't know anything, so the environment needs to provide some kind of feedback, right? So there's an objective function that, based on whatever the outcome of the chosen actions, there is the reward function that calculates how many reward points that the agent will get for each episode. And the idea is that you have many, hundreds or maybe even thousands, tens of thousands of episodes. And maybe at the end of that, the learning agent is supposed to be trained at that point, and it can make the right decisions. So that's the general idea. And so we have actually taken that idea, that reinforcement learning idea, and by the way, we are using MATLAB reinforcement learning toolbox, but you can use other reinforcement learning framework as well. But this diagram here just kind of tells you, in our use case where we have some kind of network, a network is composed of many different nodes. The learning agent, in this case, they need to be able to figure out how to best attack each one of these nodes here, which is the diagram on the upper right-hand corner there. And then based on the reward function, is going to help the objective function is going to help the learning agent to optimize and to be able to realize that objective, essentially. So maybe at the beginning, it's the learning agent isn't doing too well because it doesn't know anything. It's just randomly picking some actions from the offensive playbook, and maybe it's not really accomplishing anything. But hopefully over time, over many episodes, it's going to make the right decision. It's going to learn to say, oh, okay, for this node here, I need to use this particular tactic or this particular technique to compromise this node to meet the objective. And then the objective might be to break into the system, to shut it down. And so that might be a violation of availability, or maybe, trying to steal some data, that's a, breaking into the account and then steal your social security number or something like that. And so that's a violation of integrity and then confidentiality, for example. So that's another, metric that you can use. And then you can use these metrics to basically set up your objective function. And so there's a lot of, trial and error, because there's no one size fits all, depending on what you would like your learning agents to do on the, if you're red teaming a system. And then obviously on the defensive side, how you can, mitigate would be, based on what the attack agents are doing to your system, what are the corresponding defensive technique that you can use. So so that's the reason why we construct those playbooks essentially. And so so this seems to be working, and so we had quite a bit of success. We have tried on different network topology for different use cases. It can be an IP-based system, can be ICS, OT type of system, operational technology system, where you might have SCADA system and so on. So the same thing can be applied in different use cases, different operating environment. And so the other step that we wanted to take is to evolve that single learning agent into multi-agent, right? It's not just one agent that's making all the decisions, because we find out that this would give a little bit more flexibility. Cyber is very dynamic. There is different ways to put together a system or a network. For example, a network might be more than just your laptop computers, your tablets, iPads or whatever. It might be, your cell phone, for example, or maybe OT system like SCADA system and Alexa or whatever, right? So the idea is that because of that flexibility, and then also because of the dynamic nature of cyber, there are so many different attack vectors at so many different levels within the OSI. If I can refer that to the 7-layer OSI architecture model that people are typically familiar with, for each one of the layers, there are millions of attack vectors out there. And so so in order to better represent or have the fidelity to select these attack vectors, we think that it's better to have multi-agent instead of one single agent that does everything, because we find out that even though conceptually it works, you might have a collection of systems that might be different. So you might have a family of systems instead of just a system of systems. And so it might be a good idea to have multiple agents. And so that's the reason why we are kind of approaching it down this multi-agent reinforcement learning framework. And so you might have one agent training specifically for initial access, and then another agent specifically training for lateral movement, and then command and control. And by the way, those are the attack framework that that we got there. So let me see. So yeah, I was trying to get back to the attack. So hold on a second here. So this is the attack framework. So what I was just saying is that that you can have each agent that's focusing on each one of these tactics out there. So one agent might be focusing on the initial access, where it can select any one of the 9 techniques out there, and then you might have another one focusing on collection or lateral movement. I think that's my example that I use. So you have another 9 tactics there, and so you can have a little bit more flexibility from that standpoint there. So that's what I was trying to explain. Let me continue. And I'll save a few minutes for questions as well at the end. So we have this multi-agent environment there. And so, this is exactly what I was trying to show, is that you can have specific agents focusing on specific techniques or tactics in this case here. And so I think that's why that is useful. And then this is an example of this. Obviously, this is a very simple network diagram, network topology. So we put together like a minimum viable product there to demonstrate this proof of concept. That was almost 2 years ago now. And so the idea is that if you start from one node, which is this purple node on the upper right-hand corner there, if you want to ultimately compromise this particular pink node there, what are the attack vectors that you want to exercise on each one of these nodes? And also, by the way, it also needs to figure out what is the best path to get to here. You can go down, go up, go across, or just go across and then come up. So there are multiple paths, and so we are basically testing to make sure that the learning agents are indeed learning. And so we know that that this approach actually works because with the objective function, we can algebraically pre-calculate. In this very simple example here, by the way, we can calculate what is the maximum number of reward points that the learning agent or agents will ultimately get. And so we have in this case we have pre-calculated the maximum number of reward points, and then we wanted to see if the learning agents will indeed produce the same number of points, and obviously they did. So that tells us that that the learning agents, they are making the right decisions, and so that gives us a little bit more credibility and to kind of validate our whole approach. And we kind of so within the AI machine learning world, there's the concept of explainability or XAI, explainable AI, really just trying to make sure that the AI model is indeed making the right decisions and that it's not biased and so on and so forth. And so in the case of reinforcement learning, this is our approach, at least. I mean, there are many approaches out there. If you doing a kind of an image classification or problem, you can kind of zoom in and kind of for each pixel here, there are X number of pixels, and then you want to figure out which region of the picture will make the learning agent say that, oh, this is cat because it's got pointy ears as opposed to round ears or something. Oh, that's a bear because it's got round ears or something like that. So the region where it shows is the ears. That's the area that can provide some XAI there, because it tells you this is why that is making the learning agents into making certain decisions. So that's a very simple example, obviously, but in this case here, we're not dealing with pixels, we're not dealing with pictures, we're dealing with numbers essentially. I mean data in general. So this is kind of our way to check, to at least from the algebraic standpoint, why we think that the learning agents are making the right decision. And so that's what we have done. So in summary, I think this is my last chart here. So we have demonstrated at least put together this proof of concept MVP to demonstrate how we can use a simulation-based framework and then have it train the learning agents. We have done this in this kind of a cyber environment. We have done a similar IRAP project, the research and development project, and we are focusing more on 5G. And so we have done similar thing, and that also worked in our use case as well. So we have, fairly high confidence of how this approach actually works. And we can certainly extend this to a much bigger scale scenario. The example that I showed you earlier, it probably took a few hundred or so episodes, and certainly if you have a bigger scenario with many more nodes than what I had, I think I probably had 12 nodes or something like that on the network. You have a bigger network, certainly it's going to take much longer, but hopefully we can use the high performance PC to speed things up. Just basically throwing clock speed at the problem there. So that may be one way to improve the training time. And then the other thing is that we have provide food traceability from the standpoint of how we actually train the learning agents, all the way down to what are the reward points, what's the maximum number of reward points, and whether or not the learning agents actually achieve that. And so by simply the fact that they did indeed score the same number of points, that gives us pretty good confidence there. But certainly, as I said, cyber is a very dynamic environment. You might have a different scenario, so we need to do some more experimentations. But in general, I feel pretty good about what we have done, and certainly it's a different use case. And then we can also use this as a way to support mission planning. As I said, red teaming, that's one thing, but also trying to better anticipate what the adversaries might be doing to our system. So there's kind of a mission planning aspect, mission rehearsal. How would you react if the adversary is attacking your admin accounts, your default account, or they exercise some kind of rainbow password hack? What are the things that you can do? Or you can actually use this as a way to say so you deploy new technology out there. Maybe it's a zero trust architecture, ZTA, or you use post quantum cryptography out there. What is the probability of success out there? So you can actually run all these Monte Carlos, and by using the AI machine learning agent that we have here, that can give you some sense of the level of success. And then the other thing I also pointed out is that so DARPA, a couple of years ago, they had the Alpha Dogfight. Basically, it's a situation where you have the AI piloted aircraft doing a dogfight with human piloted airplane, and they have shown that AI system can actually outperform the best human pilots out there. And so but basically what I'm trying to say is that we can do almost the same thing in our little cyber wargaming world, where instead of air-to-air combat scenario, we can do this within the cyber context. And by the way, we can also add add some of the say RF radio frequency jamming and so on, so we can also throw that in the mix as well. So all in all, I think that that's just a interesting experiment, and we can certainly do AI versus AI. And also maybe have a AI team versus another team of human operators, for example. So it's got different combinations. So I think it's you can certainly do mix and match, and I thought that this is a fairly interesting work that we have put together here. So with that, I think I have a few more minutes. Any questions or comments for me?
Attendees, if you have any questions, please drop them in the Q&A feature down below. While we're waiting on questions coming, Ambrose, I want to let you know that just a few minutes ago, I got a very big smile on my face. Whenever I am asked to introduce or give the typical elevator pitch on who is CERIAS, the pitch goes, CERIAS is a standalone institute at Purdue University that studies cyber and cyber physical systems. Our research focal areas include security, privacy, resiliency, autonomy, trusted electronics, and explainable AI. And often they'll say, what is explainable AI? So it was rewarding to see, and I'd actually had not seen the shortened version of XAI. So I will probably start recycling that in my proposals. So thank you. It was a fascinating presentation. Students, again, or any attendee, doesn't have to be a student. If there are any questions, please drop them into the Q&A feature. Personal side note, Ambrose, I'm going to provide an introduction to you to one of our alum who I think you would be like-minded, and he has spent a long time in DoD and has struck out a few years ago with his own company, but is not doing wargaming. But I think he would find your research interest, and I think that you would find his research as well. Okay, we do have one question that came in. Logistics question. How does attendance... Oh, okay. Ambrose, is not a question for you. Students, you should be logging in through Blackboard. Adam, please correct me if that is incorrect. I did want
Brightspace.
Brightspace, thank you. Brightspace. You log in through Brightspace, and that will automatically keep the attendance. For those of you who are taking this class for the very first time, it is pretty easy to pass this class. Just attend the lectures. And even if you have a conflict and you can't attend a particular week, you can view the recording afterwards and then just write a short paragraph that basically lets us know that you really did watch the video. So any questions specifically for Mr. Cam? Okay, while we again wait just another minute or two for questions come in, I will ask a quick question of you that is not related directly to your presentation, but I have heard in my meetings with Lockheed Martin, there were about 40 or 50 engineers and technologists on campus just before the holidays. Are you looking to hire students for interns or careers in your business unit?
Oh yeah. We're always looking for people. I think we have hundreds of racks out there, and I mean each summer we bring in summer interns and co-ops as well. And I mean if that's something that you guys would like to pursue, let me know. I have a point of contact that you can kind of follow up on.
So students there, Lockheed Martin is littered with an awful lot of Boilermakers. I think in every single business unit across Lockheed Martin, but certainly within the focal areas of cyber and cyber physical systems. In the 17 years now that I've been with CERIAS, I know a number of our students have gone and had both internships and absolutely wonderful careers in Lockheed Martin. So if you are looking for an opportunity, their website is quite fantastic in just doing keyword search to find a number of jobs, including the various geographic regions that they could be in. Ambrose, what is the specific business unit or Lockheed company that you're with? If somebody wants to aim to see if they can work with you specifically.
Yeah, so I'm with the Rotary Emission Systems, so or RMS. And so that's the business area that's composed of Sikorsky aircraft, your helicopters, and also we have folks that are working on the Navy system like Aegis. If you have heard about Aegis destroyers, also have a lot of command and control systems as well. So and then the other business areas. So Lockheed Martin has 4 business areas. RMS is one of them. We have Lockheed Martin Space. They focus on the space things, so that's really interesting. And then Aero, so obviously their franchise program is F-35. You have Missiles and Fire Control, MFC, and so we are definitely one of them. And then I think that there's a lot of different opportunities out there. So
every business unit is hiring cybersecurity talent.
Yeah, that's correct.
Yeah. We do have a question that has come in for you. I'm going to read it verbatim here. Have you entertained the idea of using other simulation modeling software, AnyLogic, etc., for the agent-based modeling?
Yeah, that's a great question. So yeah, we have used different simulation tools. I'm a big fan of simulation. I started off as a simulation engineer, even though my title was a systems engineer. But yeah, we have used lately when I was talking about the 5G project that I mentioned. So we use SDK, Systems Toolkit, Exada, which is another commercial off-the-shelf tool, and then MATLAB 5G as well. So yeah, we have a collection of simulation tools to train our learning agents. And we have had strong success.
Ambrose, there you at the bottom of the screen, probably the same as mine, is the Q&A feature. I'd encourage you to open it up, but I will read this next question, but sometimes reading it yourself is better than hearing me drone on. Your demonstration showed an attacker trying to find a point of entry through the edge router. Can you execute more complex foothold techniques, such as detecting a vulnerable web server and using different attack methods to try to gain an initial foothold?
Yeah, that's a good question. Yeah, so in our use case there, at least that one that I show you, we assume that the adversary, they already have a foothold on the network, and then so it's just really just a matter of compromising each one of the nodes before the adversary gets to the destination, which was that upper left-hand corner the node there. And then so but essentially, yeah, we oh yeah, and the reason why we wanted to do it that way is because in our setup, at least, we have to specify the source and the destination, and then basically the source and the targeted node. And then for each one of these pairs, what are the attack vectors? And I don't know if I have it in the chart here, but yeah, I guess you can't really see it clear. Oh yeah, yeah, it's not that clear because I kind of chop it off there, but you see the ID node and then the string of attack vectors. So it's actually a pair. It's the launching node and then the targeted node out there. So that's how we kind of construct it. Yeah, I guess this is the assumption that we made in this particular case. Yeah, but it doesn't have to be like that, obviously.
Excellent. Well, we are at 5:20, the official closing of the class. Oh, I'm sorry. Another question did just pop in here. Let's take that. Two more. What do you think is the best way to use the MITRE attack website to try and memorize all many attacks as possible, or to use it as you feel the need?
Yeah, I think that well, that website has been updated from time to time, and so I think that is used to use that as a reference. I wouldn't encourage you to memorize the whole thing, but I would certainly encourage you to maybe scan that website and then kind of grab it from time to time. Grab the data. That's what we have done so far. So yeah. And the same thing with some of the other ones as well, like the one that I mentioned, the one with the CVE, which is National Vulnerability Database. That one has periodic updates. And each year they may have tens of thousands of new attack vectors, new CVEs, and so yeah, so that's another way to kind of make sure that your CVE database is up to date there.
So CERIAS operates as a pseudo consortium, and there's 21 partners or consortium members, and MITRE is one of them. We've had a relationship with MITRE going back probably 25 years, actually probably before the founding of CERIAS. And so small trivia here is that we are actually part of the team that helped develop the CVE system back many, many years ago. But I can tell you one of my favorite things when I do go to a cybersecurity trade show, if MITRE has a booth there, they're almost always handing out attack vector posters. Now, of course, just so we talk about, the website gets updated, so your poster eventually is probably going to be outdated. But I've been in many a cybersecurity engineer's office and have that attack vector poster on their wall. So it is a very useful website. One more question here. Would anything change if the adversary is aware that you are using such an approach to identify optimal attack vectors? For instance, can it try to attack your RL algorithm?
Yeah, so this person read my mind there. So yeah, that's certainly something that we are very concerned about, right? So I talk about the XAI, and I also kind of mentioned about the adversarial AI as well. That's another topic that we are actually looking at, is really the not just the protection of the data and the network itself, but also the RL, the AI engine, if you will. And so yeah, we have been talking to MITRE. They have what's called the Atlas framework. I don't know if you guys are familiar with that, but it is a kind of similar to attack, but it's more focused on the AI engine and how you would protect it, and so, or at least identify vulnerabilities there. So yeah, so we are talking to them as well. That's another research area that I'm very interested in. Yeah.
Ambrose, thank you very much for joining us. It was a pleasure to have you virtually. I hope we have the opportunity to have you in person on campus at some time. And just as you had started your talk, I dropped in the chat feature primarily for the use of the attendees to see, but I'm gonna basically share that information for them as well as you. The 24th annual CERIAS Cybersecurity Symposium will be held in person live at Purdue University on March 28th and 29th. The lineup is, if I do say so myself, is pretty phenomenal. I think it's going to go live within the next couple of days, as we have gotten a couple more confirmations of speakers. It will be in person only. Please mark your calendar now. And we hope to see you in West Lafayette at the end of March. Note that it will also be the kickoff of the 25th anniversary of CERIAS. So yes, there will be cake. With that, we'll wrap up today's session of the CERIAS Security Seminar. We appreciate all the attendees and obviously Ambrose for taking the time to speak with us today. See everybody next week. Bye-bye.
Right.
Thank you,
guys.
Ambrose.
All right. Appreciate it.